Mr. Sarjerao Bhawar. Mr. Sarjerao Bhawar is a research analyst at Blue Star India with around a decade of experience. He did a master's in thermal and fluids engineering from IIT Bombay. Mr. Sarjerao worked on new product development of HVAC and refrigeration products to meet performance requirements per regulatory standards of India, SAARC countries, Middle East, European, and North American markets. He was part of a recent new product development assignment of North America and European markets involving alternative low GWP refrigerants such as R454B, R454C, propane, isobutane, CO2, R1234YF, etc. to replace current high GWP ODP refrigerants in air conditioning and refrigeration applications. Today, Mr. Sarjerao will talk about global refrigerants trends in HVAC industry. So delegates, let's welcome Mr. Sarjerao.
So today, like a lot been covered, the basics about the refrigerant and what is happening in the industry and across the globe and like what transitions happening. So I will, take you through what are the refrigerant trends in HVACR industry globally and associated standards involved and like how the decision making involved and are we there yet? That's the last question I would like to address. So basically we know it is a transportation medium, transfers it from the cool surface to hot surface, similar to our circulation system, like we have blood. So it's analogous and like we can say, it transfers, some packets of energy from cold surface to hot surface. However, if you look at the history, so history says something like we started somewhere 1834 when VCC was developed. VCC was invented with the natural refrigerants. So previously those refrigerants were CO2, SO2. Obviously, I mean, those were that time, that era, those were not suitable because of SO2 got, reacts with air, air and form H2SO4, CO2 were high pressure systems. And there were problems associated with those during the 19th century or early 20th century. But we overcome those challenges in 1930 to 50. We invented some safe refrigerant. We call it CFCs. And we were like thinking, okay, that's fine. Okay, we got something innovative, and like then we got into the cycle. Like in 1970, we found ozone depletion. Then Montour Protocol in 1987. So we started phasing down SCFCs. But then when we again further did our research, we found out in 1995 there is a global warming issue. So Kyoto Protocol takes into place, and that is basically trying to phasing down HFCs. So today we are discussing about HFCs, high GWP HFCs like 134A, R410A, 407 high GWP HFCs, which are in phasing down mode. So ultimately we are trying to reduce GWP values lesser than 1000 number. So today we are somewhere at 2023 discussing about the refrigerants like HFC, low GWP HFC, of course, with the HFO or HFC, HFO blends or natural refrigerants. So that's the thing we are talking about. But like, is there anything beyond? Like whether this cycle gonna repeat, or is there anything further after this 2023? That's we need to really think upon. However, let's understand some of the selection, like how HVACR industry. If any regulation comes in, so industry point of view, what industry thinks about cost of investment, that is per kg cost, whether that will be complete new tooling or new equipment cost involved, or it will be existing system. Just I need to change the refrigerant. I need to check my pressures, discharge temperatures, safety. Like we talked about toxicity, we talked about whether it is flammable, or enough research is available, enough references are available that this refrigerant is used, analyzed, and it's safe. Environmental perspective, we talked about TEWI, that is total equivalent warming impact, which says about the direct emission. Also talked about indirect emission, that is combination of those two factors. GWP, we all know global warming potential that is driving this whole refrigerant scenarios here. Energy consumption, gas regulation, or the Kigali agreement, or whatever the regulations coming in. So that industry also thinks about that. Even though if you consider operating costs like in US, Europe, there are some benefits given to the consumer when certain energy consumption requirements, or if industry follows some low GWP refrigerant, some benefits given to the consumer. So industry also think that perspective, whether I would which refrigerant I will be choosing it. So that is industry point of view. But when you think about like thermodynamic or physical environment point of view, it should have some low boiling point, small discharge pressure, small pressure ratios, to have better, efficiencies. The thermodynamics talks about the better efficiencies, but the therm physical and environment point of view, ODP should be zero, JWP low, should not be toxical, should not be flammable, good stability, good compatibility with all the materials. It should be miscible with, lubricants, leak detection. If at all it is A2L or A3 or B2L, it should be detectable. So these are some selection criteria as we look upon. However, ASHRAE says we need to, even in order to select the refrigerant, we need to, classify them in some of the, categories that we already discussed about. In vertically, we, categorize as how the flammability goes in A1, A2, A3. There is one more category, A2L, put in, to categorize and to subcategorize A2 into A2L. And horizontally, we see toxicities. So lower toxic or high toxic. So that defines how the refrigerants are classified as per the safety norms. However, there is talk about A2L a lot because the most of the industries, if you look at it, is moving towards A2L refrigerants. And how we, how we can, define those A2L refrigerants. So just quickly, I will just like to, show you how the A2L is differentiated when with respect to the class 2. So A2L is differentiated based on the burning velocity. So what burning velocity means is how reactants move towards the flame. If that velocity is less than 0.1 meter per second, it's 2L. And beyond that is class 2 refrigerant. And 2 and 3 is specifically class 2L or class 2 and class 3 are basically distinguished based on the two factor, that is lower flammability limit and heat of combustion. So 0.1 lower flammability limit, example like 0.1 kg of refrigerant in 1 meter cube. And if ignition source is present, if that refrigerant lower flammability limit is 0.09, let's say, then that categorized as a class 3 refrigerant, since there is a chances of, increasing probability of combustion event. And even plus, it should have more than 19,000 kilojoules per kg of heat of combustion. So that is the thing. That is how these are, distinguished as per ASHRAE, and a lot research put into, distinguish into these categories, that is subclass 2L. So this is how we classify it, and then we understood some of the terms. We discussed about some of the terms are global warming potential and TB factor. So we already know benchmark is CO2, and as per that, we call it like there will be some of the category, like there will be some of the refrigerant having higher GWP levels, single digit GWP levels in HFOs. Hydrocarbons got single, some of the refrigerants are single GWP levels. And there is something called as total equivalent warming impact, which talks about the global warming, which is if refrigerant is leaked into the system, and indirect, which is because of the energy consumption. So ultimately, I'm using that refrigerant in my systems and my systems are performing worse, or it is not energy efficient. That will cause more energy harm or more harm to the environment ultimately. So that's how this TEVI is taken care into account. There is one more term that is, cycle, like total, like there is one more term, to address the further on beyond TV. I'll not get into that, but before, like, I would like to, gone through some of the basic terms about the refrigerant. So this is where we wanted to understand more on the global perspective, how the refrigerants are moving across the globe, which parameters affecting those refrigerant change, and those we know already. But we known for sure that we are moving to A2L. So A1 is already gone. We are moving towards A2L, and A2L, how this A2L or A3, how these are put on this global map. So if you see the USA market, which is more driven by the ASHRAE 15 standard and which is linked to building regulations. So as of now, USA did not accept A3 refrigerant. They just accepted A2L today's date. So they have strict charge limitation up to 150 grams. They have not moved beyond that. So that's the USA scenario, that is North America market scenario. Europe has got hydrocarbons as well as CO2 systems coming in, even A2L refrigerants coming in, which is driven by EN 378 standard, which is linked to compliance with Europe laws, which are like as per the MTM PAD directives. So in Indian market or the Asian countries, if you look at it, India, China, or Japan, wherein we try to follow ISO 5149 standard, wherein we have got, as per Kigali Agreement, we have Kigali Cooling Efficiency Program. So it talks about, how, we trying to reduce the indirect impact by designing high energy efficiency system. So that's how this KCEP came into picture, and that particular KCEP is the mother of our ICEP plan. So that Indian country like cooling plan arrangement, India cooling action plan, what we're talking about. And in China, there are some of the which is driven by the GB 9237, which corresponding to again ISO, and that also drives higher efficiencies in their systems. So this is how the global scenario look like for A2L or the hydrocarbon or A3 refrigerants. So talking about global refrigerant trends across like application wise. So top of the application shows the air conditioner and heat pumps, how this refrigerant present scenario, mid-term and long-term scenario, how this, gonna change across the industry for air conditioning and refrigeration. So we know all like R134 is dominating centrifugal and screw chiller. We are moving towards 1234 Cherry 513. Long-term perspective, 515B or 1234 Cherry will be the solution. So this particular image is taken from I'll take a courtesy of Danfoss, where they have presented this white paper, which is recently modified in November 2022, and most of the images or the content is coming from them, because the Danfoss is global player, and I would like to mention that, since they're being a courtesy to them. However, now scroll chillers, which is scroll chillers or air handling units, low temperature heat pumps, ACs, or these ACs, VRFs, central air conditioning systems, these are more dominated by R410A systems. But when regulations coming in near terms, near future, we are moving towards 32454B or some of the cases, R454C, most of the cases. But long term, if you look at it, industry looking at these refrigerants, which are predominantly moving towards either HFO or HFO blends or R32. And some of the cases R290 as well. That is the ACs and heat pump scenario. But now refrigeration industry has got a lot of refrigerants. Currently, most of the industrial application is already, it always dominated by the R744, that is ammonia or CO2. But the centralized supermarkets, we have 22404, which are getting, transitions towards 448 or 744 or 449A. Process chillers, again, we have got some of the refrigerant like 2234 and 744 transitioning towards HFOs or CO2s. Condensing units, low temperature condensing units, again transitioning towards 448, 449A, 452, which are again HFO based blends, and 290 as well in long-term perspective. We have some self-contained units which are dominated currently 600A, 290, which try to be continued, but the high GWP still 134A will be there. That's the thing Danfoss is saying. But 513 and 1234YF, which are HFO-based refrigerant, will get into a long-term perspective. So this is the slide this is basically the first slide, like what I talked about, and this is how the refrigerants are moved towards the flammability line. So this is how we are moving towards. Most of the refrigerants are either HFOs or the A2Ls, which are distinguished by using this flammability line. So that's we already talked about, and some of the alternate substitutes are HFO based, the HFC or the HFOs. But the real question is whether HFO dominates, whether HFOs are the solution or not. So this is my last slide where I would like to put in this question mark, whether HFOs are a solution or not. Since we have as of now we have seen HFOs are dominating, but there are something called as TFAs, that is trifluoroacetate acid, which is getting formed when HFOs are released in the atmosphere. And if you look at the 1234YF, which has got 100% conversion rate, so yield is 100%. And research is going on whether to include this into F-gas regulation or not. As of now, these are not included, but this will be, soon, this will gonna, happen that it will get included. So with that, I would like to, end my topic.